Good day! So ngayon, ang topic natin ay yung area under a curve. Now, this is almost a direct application no, of the concept of the definite integral. So there's no really separate lesson for this, but rather, dediretso tayo sa pag-solve ng exercises. Tapos, i-differentiate natin yung definite integral sa area, kung ano yung hinahanap natin. And for this video, I have 4 exercises na dadaanan ko. And you should have seen no, yung 4 na problems at the start of the video bago siya mag-proceed. So, if you want to try out muna na sagutan sila bago natin sila i-discuss, you could pause this for the meantime, go back and look at the questions, try to answer them, just keeping in mind kung ano yung definition natin ng area at ano yung pinagkaiba ng definite integral sa area, and come back sa video and let's compare our solutions and our answers. So we want to find the area of the region in the first quadrant bounded by the curve y equals x squared plus 1, both axes meaning yung y-axis tsaka yung x-axis, and the line x equals 2. If the y-axis is one of our boundaries, then that means in this figure, makikita naman natin dun sa figure, yung interval natin is from 0, kasi y-axis hanggang dun sa second na line na binigay, in this case, x equals 2. So we want to find the area of this region yung naka-shade dito. You'll notice this is exactly the same as asking for the definite integral from 0 to 2 ng function na y equals x squared plus 1. But it's phrased as an area question. So let's proceed. Let's take a look at this region. Magdodraw ako ng approximating rectangle. So this would represent the ith subinterval. And in the ith subinterval, meron tayong x sub I. So that will be the x value kung saan natin i-evaluate yung function para makuha natin yung height ng rectangle na to, nitong approximating rectangle na to. And it will have a point sa function natin mismo with coordinates x sub I, f of x sub I. And the height of this approximating rectangle will be given by f of x sub I. So balik tayo dun sa solutions natin. And the Riemann sum, which we'll call r sub n, will be equal to the sum of all such approximating rectangles. So that will be the summation from I equals 1 to n. Ano ba yung function natin? Diba x squared plus 1? So each approximating rectangle will have a height na x sub I squared plus 1 times yung base, yung width ng rectangle given by delta x. So that will be b minus a over n. In this case, it will be 2 minus 0 over n. Siguro one thing lang na gusto kong i-emphasize, na si delta x, this is also a function of n kasi it's b minus a over n. And when you let n approach infinity, yung delta x natin, it will approach 0. And at this point, I would like to point out yung similarity nung form nung definite integral na may integral symbol, ng function, tapos dx, dun sa limit ng Riemann sum, na limit ng summation, yung function, times delta x. So yung summation symbol na sabi natin para siyang letter S na in-stretch out, it's really a letter S na in-stretch out. Kasi essentially a summation din siya Parang tinitake niya yung position ng limit as n approaches infinity of the summation from I equals 1 to n. So it's essentially parang a summation of infinite terms. Although technically, it's not really a summation of infinite terms, but yung number ng terms na ina-add natin, nag-a-approach ng infinity. Yung delta x naman, nagko-correspond sa dx. So di ba nung kumuha tayo ng derivatives, yung dy over dx, nanggaling din siya sa idea ng delta y over delta x, which is yung slope. So, ginamit natin yung dy over dx, yung pinaliit na natin ng pinaliit yung length nung delta x and correspondingly delta y. So, it's actually the same idea here. Si delta x na nag-approach ng 0, it becomes very, very small. It becomes a differential value, kaya dx yung ginagamit natin. Okay, anyway, moving forward, a would then be the definite integral from 0 to 2 ng x squared plus 1. So at this point, wala siyang pinagkaiba dun sa definite integral problems natin. So let's evaluate it using FTC. And we'll have our final answer to be equal to 14 over 3. But just take a note that here we are asking for the area of the region, not the definite integral. So since we're talking about area, we should indicate units. So it's 14 over 3 square units kasi hindi naman binigay sa atin yung actual na units of measurement Okay, let's proceed dun sa second question. And I hope na na-try nyo to before, nung finlash siya before the start of the video. Let's wait for it to finish. So we want to find the area of the region bounded by a parabola given by y equals x squared minus 6x plus 5 and the lines x equals 2 and x equals 3. So again, if we take a look at the region, pag pinlot out natin siya sa isang graphing tool, ang naiba lang niya dun sa first problem natin is that it is a region below the x-axis. So if we evaluate the definite integral for this expression, we expect a negative value because the entire region is below the x-axis. But since we're looking for the area, dapat yung magiging final answer natin positive. So yun lang yung kailangan nating isipin. So we could essentially solve this as a definite integral problem and just remember na i-negate yung result natin pagkatapos. But just for consistency, let's still draw an approximating rectangle. So this will be the ith rectangle, and within that ith rectangle or ith subinterval, meron tayong x of I na value na gagamitin natin para makuha yung height ng rectangle by evaluating our function at x of I. So here is our point, x of I, f of x of I. So that means, kahit yung f of x of I natin magiging negative, yung height na yan should still be considered as a positive value. And that height is equal to dun sa magnitude ni f of x of I. So pwede natin siyang absolute value. But again, taking advantage na alam natin na this will be a negative definite integral at gusto lang natin yung positive na area, what we could do is just evaluate this definite integral. So it's a definite integral from 2 to 3 of x squared minus 6x plus 5 and apply the fundamental theorem of calculus, mag-FTC2 tayo and evaluate it using FTC. Wag na nating isa-isahin yung bawat term and let's just wait for the final result. But remember, ina-expect natin na negative value to. And this is actually negative 11 over 3. And we know that this entire region is totally below the x-axis. Ayun, so since this entire region is below the x-axis, the definite integral will be negative, but we are solving for the area, so we expect this value to be positive. Kailangan nating ibigay yung sagot as a positive value. The area of this region is 11 over 3 na nanggaling dun sa negative 11 over 3 na definite integral, 11 over 3 square units. So I hope you're able to compare your answer with this one. At sana pareho tayo. And let's proceed to the next question. So for this problem, we want to find the area of the region bounded by the curve y equals x cubed minus x squared minus 9x plus 9, the x-axis and the two lines x equals negative 2 and x equals 2. We plotted itong graph na to at itong region na to sa ating graphing software. At yung difference naman niya dun sa first two problems natin is that the region na na-encompass nung curve tsaka nung lines natin ay hindi lahat nasa taas na x-axis or lahat nasa baba ng x-axis. So there is a portion of the area that is above and there is a portion that is below the x-axis. Ngayon, kung kinuha natin yung definite integral from negative 2 to positive 2 of this function, ang makukuha natin ay yung net area. So, ititreat niya yung region above the x-axis as positive, yung region below the x-axis as negative, at i-add niya yung dalawa. Will that be the same as the area of this region? So, dapat ang sagot nyo, no. Ang expectation natin, yung area nitong region na to, yung positive value nun, mas malaki siya dun sa definite integral of this same region. Kasi nga, a definite integral will give us a net area. Here, we want the total area. So what could we do? We could subdivide this area into two separate regions. Yung region above the x-axis, let's call it region 1, and the area and the region below the x-axis, let's call it region 2. Now, siguro I'll still draw an approximating rectangle para lang consistent sa solutions. This represents the ith rectangle na in-evaluate natin at x sub I. Meron tayong point sa function corresponding to x sub I, f of x sub I. And the height of this approximating rectangle will be f of x sub I. Which means that we could still use yung idea ng definite integral sa kanya. But instead of taking the definite integral for the entire region, ang gagawin natin ay, since dalawa nga yung regions natin, e-evaluate natin yung definite integral for each region separately. So let's just note down that the definite integral from negative 2 to 2 will give the net area, pero yung total area yung hinahanap natin, like what we said kanina. And the first region will be the region from negative 2 to 1. And this is the part that is above the x-axis, so we expect a positive answer dito. To get the area of that region, we will just simply evaluate the definite integral from -2 to 1. Kasi sa 1 yung boundary nung dalawang regions eh. And applying FTC 1 and 2, which hindi na natin i-discuss, hintayin na lang natin mag-resolve yung solution, pwede nyo i-pause so you could compare kung tama yung steps ninyo, kung pareho tayo. Makukuha natin na ang definite integral nung region above the x-axis is 135/4. So we know that the area is 135/4 square units. So now let's evaluate the area of the second region, and keeping in mind na negative yung makukuha nating value ng definite integral niya. So kung gusto natin yung actual area niya, edi ipapositive lang natin yung result nito. So for the second region, we're evaluating the definite integral from 1 to 2 of that function x cubed minus x squared minus 9x plus 9. We'll apply FTC para i-evaluate siya. So hindi ko na di-discuss itong individual steps, but you should compare yung individual steps nyo with what I'm doing here para makita nyo kung pareho tayong ginagawa. By the way, why did I encircle these 2 points? I guess I just wanted to point out kasi itong mga terms na to, yung nakabilog sa yellow, sila yung pag in-evaluate yung function at x equals 1. So, dapat lang pareho sila ng result, no? So anyway, let's continue the solution. This will give us a definite integral of -37/12. Again, we're looking for the area and this is entirely below the x-axis. So kahit yung definite integral ay negative, yung area niya, iti-take natin as a positive value. So what we'll do is we'll combine yung areas nung first region and yung second region to give us a total area. And that will be equal to, so 135/4 plus 37/12 na kasi ginawa nating positive yung -37/12. And our final answer is 221/6 square units. Okay, so let's move on to our fourth and final problem. Again, pause this and try to answer it on your own or kahit nung sa start. Given the function f of x equals 2/x, ito yung graph nung function na yun. Hindi ko yata nasulat, but yung objective natin dito is we want to find the value of k such that the area of this region is equal to 4. So this region is the area bounded by our function y equals 2/x, the x-axis, and the lines y equals 1 and y equals k. So our goal is to find the value of k. So again, we observe that this is above the x-axis, no? So we could just use a direct application of the definite integral and write this as the definite integral from 1 to k of 2/x. And this is equal to 2 times the ln of the absolute value of x, evaluated from 1 to k. So this is equal to 2 times ln of k. Okay lang yon. K is positive. Nakita naman natin sa graph. So we could drop the absolute values minus ln of 1. But what is ln of 1? ln of 1 is 0. So again, we could further write this as 2 times the ln of k. At ano yung alam natin from the given? Alam natin na itong 2 times ln of k, this is equal to 4. So solving for k, we have ln of k is equal to 2 or k is equal to e squared. E is the Euler's constant, 2.718 something. And since this is a constant, we're done. Kasi yan na yung value nung k na kailangan natin. So for this topic, this is actually very similar dun sa discussion natin on the definite integral. Yung pinakaiba lang niya is that when we evaluate the definite integral, it's still an area concept, pero may sign na yung regions above the x-axis positive, yung regions below the x-axis are considered negative. When we're looking for the area, when we are being asked for the area, then we should consider the total area, even if the regions that we are considering are below the x-axis. So parang this is just a language issue. Wala tayong masyadong difference from a mathematical computation calculus perspective. But we just want to differentiate na pag area ang hinahanap versus definite integral yung hinahanap. May cases na pareho lang sila, but like the third problem na may region above the x-axis at region below the x-axis na magiging magkaiba yung sagot depende kung ang hinahanap ay area or the definite integral. So since this concept naman is very similar dun sa definite integral, wala na muna tayong susunod na videos na may examples. So this will be the only video for this week. So until next week, salamat sa pakikinig.